Okay, so now I think I can probably share this in a chat. I think that's the easiest. Find the chat. Where's the chat? Yeah. Okay, so you can go to this collab, and then I'll give you like a minute to start it. Let me know if there's any issues. Were you all able to load it? Okay. So in this section, what we want to do is we kind of want to try to run the analysis that I was just showing before, where we do principal components analysis on actual gene expression data. And this is specifically this TCGA data set with the 1,100 RNA-seq samples. So if we execute this, I think it first has to connect to the node, so that might take a second. Okay. Okay, so once it's like green, then I think you can execute these cells. So first we import some stuff. And then this one is just downloading the data and getting in the right format. So this file is 150 megabytes, so it takes like a couple of seconds to load. And then as we had it before, calculating these principal components goes like super easy, right? So there's literally 2 lines to do this. So the first one is initializing this principal components object. And the number of components, we basically tell it how many components it should compute. So you can increase this to the dimensionality of your data if you wanted all principal components. If you're just interested in the top ones, then you don't need that. For example, here, we just want to plot the first 2. So instead of 20, I can just calculate the first 2 principal components. So then this object has 2 columns. And it will be a bit faster this way. So it's the only thing. So this algorithm is pretty fast. And then if we plot this, this is what we get. So it's not super nice as the other plot that we've seen, but it basically did what we wanted. So we have 2 new dimensions, principal component 1, principal component 2. And then each point represents one of the 1,100 breast cancer samples. Then in this object, once we calculated the fit transform, we also have this explain variance ratio. And so I should go back to 20, just a second. There was a reason why it was 20, I suppose. So here, what I want to do is I just want to plot the variance of each of the principal components. And so you can see in this case, the first principal component contained about 24% of the information or variance, and then 14%, 6%, 4%, and so on. And then if we plot this as a bar chart, this is kind of what this looks like, right? So it's similar to this red line that we had before, like the variance in these principal components drops off pretty quickly. Okay, so that's that. So now we go through the rest in a little bit.